Welcome student. This is Professor Meenakshi Panchal from Electronics and Telecommunication Department, Parvatibai Gyanba, Mojai College of Engineering, Voguli, Pune. So in today's lecture, we are going to discuss about timers and its mode of 8051 microcontrollers. A microcontroller has two 16-bit timer or counter registers, namely time 0 as T0 and timer 1 as T1. Both these registers can be configured independently to operate as a timer or an event counter. They can be used as a timers to generate a time delay or as a counter to count event happening outside the microcontroller. When the microcontroller used as a timer, the register is programmed to count the internal clock pulse. The internal clock pulses are generated from the constant clock generator. The count loaded in the register gives the constant time. The register is incremented every machine cycle. One machine cycle consists 12 oscillator periods, and so the counting rate is 1/12th of oscillator frequency. When used as a counter, the microcontroller is programmed to count the external pulses. The register is incremented in response to high to low transition of the corresponding external pin of T0 and T1. The external input does not have any constant frequency and hence it is not used for timing reference. In order to recognize the low or high transition, the microcontroller requires two machine cycles, that is, total 24 oscillator periods. The maximum count rate is 1/24th of oscillator frequency. There are no restriction on the duty cycle of the external input signal, but it should be held high at least for one machine cycle. To ensure that the input is sampled at least once before it changes. The timer mode can also be used for pulse width measurement. When the gate bit is kept 1, the timer runs until the INTX pin is high. Hence, the timer is counting the number of internal clock pulses for which pulse on INTX pin is at high. The timer count 1 to 10 and crystal is of 12 MHz. It indicates the pulse of INTX pin was at logic 0 high for 10 microseconds. Timer 0 and timer 1 register, we can see how the register of these two timers are organized and what is the size of these register. Let's see one by one. Here the figure shows, this figure shows timer 0 and timer 1 register. The counter or timer registers are divided into two 8 bits register called as TL0 and TL1. Here the timer or counter registers are divided into two 8-bit registers. The one is called TL0 here and the another one is called TL1. TL0 and TL1 and another one is TH0 and TH1. There are two total timers and counter. The TL0, and TH0 that will forms together 16-bit timer. And TL1 and TH1 forms 16-bit timer 1. These registers can be accessed like other register A, register B, R0, R1, etc. This is the timer 0 register and this is timer 1 register. There are two timers, timer 0 and timer 1. Timer 0 forms, timer 0 includes 16 register as TL0 and TH0, and timer 1 includes a 16-bit register TL1 and TH1. The counter action is controlled by bits in the SFR timer mode control register called T mode, and the timer and counter register is called TCON, and some instructions. There are total 8-bit register. The figure shows T mode register, and this figure shows TCON register. This one is a T mode register and this one is TCON register. Both timer 0 and timer 1 use these T mode register to set the various timer operations and its mode. Here the M0 and M1, if these two bits are set to 0, then 8-bit timer and counter TXL and TLX as 8-bit prescaler. The operation of the timer can be controlled by selecting the bits of the register of T mode, which is present in special function register of the memory. By selecting particular bits, the mode of operation or operation of the T mode can be controlled. Let's see each bit one by one. First, taking or considering the MSB bit, gate. The gate is used to program timer in PWM mode. And C to this C/T bar, it is used for selecting the microcontroller to operate as a timer or counter. If this pin is set to 0, then it will act as a timer. If this pin is set to 1, this will act as a counter. And other two bits, M0 and M1, these two bits are used for mode selection on what particular mode the timer should be operate. So these are the bit configuration which is used for controlling the operation of timer of T mode register. T mode is an 8-bit register. It is used the lower 4-bit for timer 0 and upper 4-bit for timer 1. Each case, lower 2 bits are used to set the timer mode and upper 2 bits specify the mode of operation. Let's see now TCON. TCON is nothing but timer counter control register. The special function register TCON, which controls the timer counter operation. The lower 4 inputs serves to the interrupt function, but The upper 4 bits are for timer operation. Here, the lower 4 bits are used for interrupt operation and higher 4 bits are used for timer operation. If this signal, if this pin goes low, then crystal frequency attached to the 8051 and is the source of clock for timer, that is the size of crystal frequency attached to 8051 decided the speed at which the timer of 8051 ticks. The timer frequency is always 1 by 12th of frequency of the crystal attached to the 8051. How the timer 0 and 1 started and stopped? Let's see. The 8051 timer can be started and stopped by hardware and software control. The start and stop of the timer are controlled by the software method by TR, or it's called as timer start bit, that is TR0 and TR1. And these two bits are present in a T-con register. Here TR0 and TR1. This is TR0 and TR1. These two bits are used to control the operation of start and stop operation of the timer, and it can be achieved by instruction set B TR0 and clear TR0. By using instruction, how we can set it? That is set bit TR0 and CLR TR0 for timer 0. This instruction is for timer 0. For timer 1, set B TR1 and CLR TR1. By executing these two instructions, timer 1 can be configured or control the operation start or stop of the timer. This instruction start the timer set B TR0 and clear instruction stop the operation of timer CLR TR0 till gate equal to 0 in the T-mod register. The hardware method for starting and stopping the timer by an external source can be obtained by making gate equal to 1 in T-mod register. Here TF1, that is 7th bit of T-con, which is a timer 1 overflow flag, is set by hardware on timer counter overflow or clear by hardware when processor vector to the interrupt routine. Similarly, TR1 is a 6th bit of T-con. Its operation is timer 1 run control bit. It sets or cleared by the software to run to turn the timer or counter on or off. Similarly, the TF0 timer 0 overflow flag set by hardware or timer counter overflow clear by the hardware when processor vector to the interrupt routine. TR0 timer 0 run control bit set or clear by the software to turn the timer and counter on and off. And this one is IE1 T-con 3, third bit of the T-con register. interrupt one flag set by the hardware when the external interrupt edge is detected, or cleared when the interrupt is processed. And IT1 TCON interrupt one type of control bit set or cleared by the software to specify the falling edge or low level triggered external interrupts. If I is 0, interrupt 0 edge flag set by the hardware when external interrupt edge detected or clear when interrupt is processed. IT0 is nothing but interrupt 0 type of control bit set or cleared by the software to specify the falling edge or low level triggered external interrupts. So let's see the mode of operation of timer one by one. Depending on the timer control bit of TM1 and TM0, there are mode control specification is there, and which is present in specific function register, and that is also called as T mode. The timer can be operated in any one of the mode. There are total 4 modes as mode 0, mode 1, mode 2 and mode 3. In the mode, the timer operates as a 13-bit register, that is TL 5-bit and TH is 8-bit. The fifth 5-bit in the TL set divided by the 32 prescaler to TH as the 8-bit counter. The figure shows the timer and counter in the mode 0. Here the timer is enabled TR equal to 1. Here the timer is enabled TR is equal to 1 and gate is 0. Here gate is 0 and TR is equal to 1. And interrupt pin is high and gate is high, then the timer is controlled by the external input INT, and which is allow the pulse width measurement. The TR is controlled bit in a TCON register. If the user desired some count in the register and gives the command by the TRX bit, the timer or counter will start. If the timer and counter exceeds the 13 bit, that is 1FFH, the next count will be 000H. It causes the microcontroller generates an interrupt in order to inform the programmer whether one cycle is over. To indicate it, timer overflow bit TF1 and TF0 will be set. If the timer interrupt is enabled using interrupt enable register IE, the control will vector to SFR routine. Similarly, in mode 1, timer or counter is same as the mode 0. The only difference is that in mode 0, the timer or counter was a 13-bit, but in mode 1, it is a 16-bit timer and counter. The value counts from 0000H to FFFFH to be loaded in the timer register. The mode 1 is a 16-bit timer, as the biggest count that can be stored in the timer register is FFFH. The mode 2 is 8-bit timer, hence the maximum count that can be stored in the timer register is only FFH. The timer and counter configured as a 8-bit counter TL in the mode with auto reload facility as shown in figure below here. Counter 1 is in mode 2 and which allows the 00H to FFH. 00H to FFH to be loaded into the TH trigger. The TL1 acts as a basic timer and counter. In the auto reload mode, TH is loaded. When the timer starts working, it keeps on incrementing and it will overflow. This will set the timer interrupt flag TF1 and it's also reload the content of TH1 and TL1. The reloading operation will not alter the content of TH1. The operation is same for the timer 0. Setting the baud rate in the serial communication. The application of these timer and counter is setting the baud rate in the serial communication and generating the square wave of different frequencies and display the counts. Similarly, mode 3 timer 1 is not used. The timer 1 therefore simply hold its count. The timer 0 register TL0 and TH1 are configured as two separate 8-bit timers. Here the TL0 register used for timer 0 control bits and gate and TR0, INT0, TF0 and TH0 counts the machine cycle and it takes over the use of TR1 and TF1 from the timer 1. When the timer 0 is in the mode 3, the timer 1 may be used in the mode 0 and mode 1 and mode 2. In this case, no interrupt will be generated because timer 0 is using a TF1 flag. When timer 0 is in mode 3, timer 1 can be used as a baud rate generator for the serial port. So let's see the summary. In the mode 0, 13-bit timer from TL 5-bit and TH 8-bit, total 13-bit timer and counter overflow indicated by T1 flag. In mode 1, 16-bit timer, TL is 8-bit and TH is 8-bit is used. In mode 2, reload the mode 8-bit counter from TL is equal to 8-bit, TL 8-bit and overflow from the TL not only set but also reloads TL with the content of TH. Configure the TL0 and TH0 as two separate counters. This is the introduction about timer and counter. We have seen the different modes with a brief discussion. So in the further lectures, we will see about what is PWM and some few problems over the timers and also addressing modes. This is in a further day. Thank you.